Hello good people, I'm going to delve a bit into how we name organic compounds. In order to do that, I need to talk about IUPAC. What is IUPAC? It is the International Union of Pure and Applied Chemistry. It was formed in 1919, recognizing the need and benefit for international standardization in chemistry. In short, the members of the union wanted to make sure that all chemists speak the same language. When it comes to naming of organic compounds, they have all agreed on a set of rules. Here I'm going to explore the 5 main ones that apply when it comes to naming alkanes. Let me bring in an alkane. Here it is, a nice skeletal formula. The first rule says identify and name the longest continuous carbon chain. In this case, the longest continuous carbon chain is this one here that I'm painting in orange. We only have single carbon-carbon bonds, so we are dealing with an alkane. And the longest chain contains 8 carbons, so this would be an octane. The next rule states identify and name groups attached to this chain. In this case, we have this group here, a single carbon attached to the main chain. This single carbon has 3 hydrogens attached to it, so this is a methyl group. So far I can say that I have an octane that also has a methyl group attached to it. However, I need to be a little bit more specific. I need to indicate where on the main chain is this methyl group located. This brings us to the third rule, and it says to number the carbons of the chain so that the groups end up with the lowest numbers. What does this mean? If I number it from left to right, it would be 1, 2, 3, 4, 5, 6, 7, 8. This way, the methyl group appears to be on carbon number 7. However, if I choose to number this chain from right to left, I will have 1, 2, 3, 4, 5, 6, 7, 8. And now the methyl group is on carbon number 2. The rule is telling me to number the chain so that the group, in this case methyl, ends up with the lowest number. This means I'm going to go with the purple set of numbers. And so my methyl is on carbon number 2. Finally, at least in this case, I could say that the name of this compound is 2-methyl octane. I have a methyl group on carbon number 2 on an octane. Those of you who have been paying attention might say, well, hold on, you demented cauliflower, you mentioned 5 rules. And so far you have listed only 3, and you seem to be done. Well, in this case, the first 3 rules suffice. But, because this is organic chemistry, things can get more complicated. So we need more rules. Let me get rid of the incorrect numbering in red and add a second methyl group on carbon number 3. What is the name of this new compound? The longest continuous chain is still represented by the 8 carbons, so I'm still dealing with an octane. The groups attached to the octane are methyl groups, so I can still write in methyl. Considering that I have more than one methyl group, I need to indicate that as well, and this is where rule number 4 comes in. It tells us to use prefixes such as di, tri, tetra and penta to indicate the quantity of a group present. Considering that I have 2 methyl groups, I'm going to use the prefix di. So now I have dimethyl octane. I still need to honor rule number 3 though. I need to indicate where the methyl groups are located. One of the methyl groups is on carbon number 2, and the other one is on carbon number 3. So I write 2, 3, and then dash. And the name of this compound is 2,3-dimethyl octane. What about the 5th rule? The 5th rule comes into play when we have 2 or more different groups. So far, we have been dealing with methyls only. But methyl is not the only group that we can attach to an organic compound. Let me remove the methyl on carbon number 3. And now, instead of a single carbon, I'm going to attach something that has 2 carbons. Let me explore this green group for a moment. What does it represent? This carbon at the top, or if you like at the end of the green group, is bonded to 3 hydrogens. So I could write CH3. The carbon next to it is bonded to 2 hydrogens. So I could write CH2. What would be its name? Well, consider that the CH3 group, which we called methyl, that comes from methane, now we have something that has 2 carbons. So this becomes ethyl, because it comes from ethane. What is the overall name of the compound? We are still dealing with an octane. This octane has 2 different groups attached to it, ethyl and methyl. Which one should I write first? According to the 5th rule, I do it in alphabetical order. So I will have ethyl, then I will have methyl. I still need to indicate their location numbers. Ethyl is on carbon number 3, while methyl is on carbon number 2. Note the use of dashes to separate the locator numbers with the group names. As the compounds become more complicated, there are more rules and sub-rules. But we will jump off that bridge when we get to it. For now, I want to explore a common pitfall when it comes to using just these 5 rules. Let me get rid of this structure and bring in a new one. Right now, this is exactly what we had before. So let me change it a bit. I'm going to add an ethyl group at the beginning here. What would be the name of this compound? A common pitfall is to assume that the longest continuous carbon chain has not changed. In other words, to still say, well, we have 1, 2, 3, 4, 5, 6, 7, 8 carbons, therefore this is an octane. We always need to check what is the longest continuous carbon chain. In this case, it is no longer 8. If I start counting up here, 1, 2, 3, 4, 5, 6, 7, 8, 9, now I can see that the longest continuous chain is 9, and therefore this is a nonane. And this nonane has 2 methyl groups. So far I have dimethylnonane. What is the location of the methyl groups? In order to answer that, I need to number the carbon chain. I need to decide, do I number it from left or do I number it from the right? If I number it from the left, the 2 methyl groups will end up on carbons 3 and 8. So the name would be 3,8-dimethylnonane. If I number the carbons from the right, the methyl groups will be on carbons number 2 and 7. And so the name of the compound would be 2,7-dimethylnonane. Which is the correct name? Well, considering rule number 3, I need to number the carbons of the chain so that the groups end up with the lowest numbers. This means that 2,7 is correct, whereas 3,8 is incorrect. As I can hear many voices cursing my name, I'm going to stop here. That is all for now, and I will see you on the flip side.